5x plus 4.
Yes.
Greater than or equal to x. 0.
Greater than or equal to 0. That's it. And you will solve for x. Is that okay, everyone? Yes? Okay. So now let's take a look at this set of problems, 45 through 64. And let's choose a couple from here and a couple from here, just to refresh our memory on radical notation or exponential notation. So any preference, anything that catches your eye? Okay, so I'm going to pick b to negative 1/3. So b to negative 1/3. So first let's discuss something very important. If I have, let's say, the 4th root of 3 to the 5th power, I can rewrite this as the base. This is the base. And the exponent is a fraction. Why is the exponent a fraction? Because this is a radical. Every time I see a radical, the exponent is a fraction. The power is always the numerator. The index is always the denominator. So b to negative 1/3, first of all, there is one other property. Anyone remembers what is a to negative n equal to? Because we have an exponent that is negative. A base raised to...
Sorry.
By inverse, you mean 1 over a to the nth power.
Yeah.
Perfect.
Yes.
So this is our starting point here. First, we will have to recognize that this is 1 over b to 1/3, according to this formula or this rule. This should go to your notes after class immediately. And now, can anyone, based on what we just wrote here, can anyone tell us what radical? How do I know it's a radical? Because as long as I have a fractional exponent, I know that that is a radical. And this is a fractional exponent, so it must be a radical. And what is the index and what is the power of b? The numerator is always the power of the base, 1. The denominator is always the index. So it's 1 over the cube root of b. Is this okay with everyone?
Yeah.
Would you like to choose another or we move on?
Can we do one more?
Yes, anything. Why is this necessary? You will see why in the next chapters. So here they're asking us to do the reverse. We are given a radical to come up with this notation. Here we are given this notation to come up with the radical. Here they are giving us the radical to come up with this. We need to be able to convert from one to the other. So please choose.
53 or 54?
53, fine. Where is it? Okay, so we have x squared plus 3, and that is to negative 1/2. Perfect. So first we have to take care of the negative exponent. Can anyone tell us what does this equal to?
1 over x squared plus 3.
Very good. So it's x squared plus 3 and then power 1/2. Which radical is power 1/2? I know now that power 1/3 is the cube root. What radical will be power 1/2? If power 1/3 is the cube root, power 1/2 must be
The square root.
the square root. That's it. Awesome. Is this okay with everyone?
Yeah.
Okay. So let's continue. Let's choose something from here. We're going backwards. We're given the radical now, and we want to go back to the exponential notation. And we can also choose a simplification from here. Any preference? Okay, I will choose 61. In 61, we have 1 over the square root of t to the 5th. And of course, t cannot be 0 because it's in the denominator. So first of all, let's change this into a power. Which power? It has to be a fraction because it's a radical. Which power will I have to write here? What is the fraction that is the power representing the square root? Of course, 5 has to be at the top. 5 over 2. And now we want to bring this to the top, but since it's in the denominator, I cannot bring it to the top with the same power. But which power?
-5 over 2.
-5 over 2. Perfect. You can always go backwards and say, what is this? Well, it's this, 1 over t to 5 halves. What is t to 5 halves? Well, it must be the square root of t to the 5th. Exactly as we did it before. Now, tell me if we want to simplify any of these. Any preference? Okay, 64. I mean 67, 64 paid to power 2/3. So we have several options here. I'll show you the one I like, and I will also show you the one with the calculator. The one I like is, I know that 64 is 2 to which power? 2 to the 6th. 2 to the 6th power. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and then 64. This is what I like. And this, I copy the base and multiply the exponents. So 6 over 1 times 3 over 2. I'd never multiply before simplifying. So it's 2 to the 9th. One option. Now, here's another option. With the graphing calculator, I put in parentheses, you know I love my parentheses, 64, close, power, in parentheses, 3 halves. Okay, and I press enter. And then to check my answer, 2 to power 9 has to be the same. So that's another option. And I just write 512. Okay? Now, 9 does not really need parentheses. The reason even here, in these new calculators, you really don't need parentheses around 3 halves. But how do I know what type of calculator you have? If you have an older calculator and you don't put parentheses, the calculator will raise 64 to the 3rd power and divide the final answer by 2 instead of raising 64 to 3 halves. So that's why I have to be very consistent when it comes to parentheses, because I don't know what type of calculator you have. Okay, back to where was I here? Okay, good. So I think we clarified that. Do we need anything else about domain? I hope we are in the clear with that too. I just wanted to choose now any of these equations. Please choose an equation so I can refresh your memory on the quadratic formula.
Uh, 41.
41. Okay, so we have 3y squared plus 8y plus 2 equals 0. The quadratic formula requires the equation to be set up like this. Ax squared, which is a is this, coefficient, the leading coefficient, bx, which is this, the middle coefficient, plus c, which is the free term, which is always taken with a sign in front, always, equals 0. If I do not have the equation set up like this, I cannot use the quadratic formula. Quadratic formula is applicable only after the equation is already set up in this format. The equation, the quadratic expression in descending order of the powers of the variable, the equal symbol and 0. If it's not set up like this, I cannot use the quadratic formula. Assuming it is, it doesn't matter if I have y or if I have x. The quadratic formula states that I can determine the two solutions as negative b plus or minus the square root of b squared minus 4ac over 2a. All these numbers come from here. So the first thing I do, I set it up in this format. It's already done. Second thing, I will identify that a equals this leading coefficient with its sign in front. You should always make sure that if there is no positive here but negative, multiply both sides by -1. Do not agree to work or use the quadratic formula if the leading coefficient is not positive. You can always make it positive. Don't complicate things in here with a negative leading coefficient, please. B in this case with the sign in front is 8. C in this case with the sign in front is 2. All I need to do now is just replace B by 8 and square it. Replace A by 3 and C by 2. That's all I need to do. And I determine the solutions. So I'm going to write it again because we chose an equation in y. It doesn't matter. Solution will be the same. So then y will be -8 plus or minus. This number here, no matter what b is, this number here has to be positive because you're squaring. So 64 minus 4 times 2 is 8 times 3 is 24. It doesn't matter the order. It's a product. You can say 2 times 3 is 6 times 4 is 24. 4 times 2 is 8 times 3 is 24. It doesn't matter, right? Divided by 2 times a, which is 6. And yes, we have to continue simplifying it. So -8 plus or minus, this is 40, with the square root, of course, divided by 6. And 40 is the square root of 4 times the square root of 10. And the square root of 4 is 2. So -8 plus or minus 2, the square root of 10 divided by 6. And before you say anything, it will be a terrible mistake to simplify 2 with 6 or 8 with 6. Please understand, these are terms. You cannot simplify with a factor. But what we can do is factor out a 2 in the numerator. And now this is a factor, this is a factor, and I can simplify. This is allowed. But I cannot cross in here or here. Please don't touch that. So this is -4 plus or minus the square root of 10. 2 times -4, 2 times 1. So now the final simplified form, -4 plus or minus the square root of 10 over 3. And we practice the quadratic formula. Any questions for me?
Yeah, you lost me. How did you get the 2?
I'm sorry?
How did you got -8 plus a -2 over 10 divided by 6? Then how did you get 2?
The square root of 40 is the square root of 4 times the square root of 10. The square root of 4 is 2.
Where's the 8 now?
right here. Is that what you meant?
No. It's
But
like
you-
the 2 at the bottom, the one where you write in green. The other one, yeah, that one. Yes.
2 times -4 is -8. 2 times 1 is 2.
Oh, okay.
We are factoring out from these two terms, we are factoring out 2. So I can simplify with 6. I cannot simplify in a sum. I have to factor in order to simplify. Is that okay?
Yes.
Perfect. Other questions, anyone? Other questions? Okay, let's go back then. So we practiced going back and forth from fractional exponents to radicals and back. We looked at the quadratic formula, how to apply it. We looked at domain. And now finally, I'd like to graph a quadratic function and then talk about demand and supply. And that's it. Oh, I would like to add 2 more functions here before we select. So we'll select, or I will make up a problem for you for quadratic function. So I want to add 2 more functions here. We're going to talk about those functions extensively in chapter 2. But I just want to add them here so it's a refresher for you. So 6, there was 5, right? 5, yes. 5 and 6, okay. Exponential. The exponential function, the simplest possible exponential function, will be like what we have in the calculator. In the calculator, we have 2 exponential functions. One is 10 to the x, and the other one is e to the x. And notice that 10 to the x goes with the same key with log, and e to the x is on the same key with natural log, because these are inverses of each other. That's why they, that's why they are on the same key. So the exponential function e to the x is the natural exponential function. And this is something similar to what we've been experiencing in the last 2.5 years or so. That's why they keep saying that one person gets sick today and 5,000 get sick tomorrow, and then 10,000 the next day, and then 1 million, because it's the function with the fastest growth possible. And that's why you've been hearing for 2 years, we want to flatten the curve. Or this, that would be nice. But at least flatten this curve that changed our lives in the last 2.5 years. Okay, so this is e to the x. And its inverse function, log function. So f of x equals natural log. So we're going to talk extensively about these 2 functions in chapter 2. And these are inverses of each other. Okay, I just wanted to throw them in. You don't have to worry about these for now. They come in chapter 2. They changed. It was used to be in 3, now it's in 2. Okay. So now I would like us to graph a quadratic function. I'm going to choose a simple one, or you can choose. A simple one would be something like 19 Even 18 is a simple one. These are more involved because they have vertices that are not friendly.